So in this case, we are going to consider another typical exam revision. This is a typical test of our Gauteng province that we are going to look into consideration as we are to consider. This was the first push which was given just for the first time to work out. Then we are going to also consider another one, which is the controlled test, exactly the one which was written as the controlled test for the same March 2024 exams, so that you can see how questions might be given. From there, you can familiarize how these questions mostly are given, working with the introductions. And these questions that we are going to be working with, it can be very, very useful. All right, so not going to waste much time, guys. Make sure you go through the instructions and information. Make sure that you read all the instructions, mostly that if necessary, your answers should be rounded off to 2 decimal places unless stated otherwise. So make sure that you go through each and every instruction that you're given, information that you're given there. So on question number 1, without wasting our time, we were given 1.1 to solve for x. Solve for x. So they are equations, inequalities to be solved from this. All right, so let's consider the first part that we are given. That's an equation there on 1.11. We are given this equation, which is 2x squared minus 7x is equal to 0. So as you can see, guys, this is our basic quadratic equation, which can be factorized by factorization, which can be solved by factorization, guys. They're just two terms here. Working with the binomial, guys. X is common. So factor out x. That is going to be what? 2x squared divided to x. That's going to be 2x minus 7x divided to x was going to give us a negative 7. So that's equal to 0. So remember, guys, each of these two must be equal to 0. One of these, so x is supposed to be equal to 0, or this other bracket of 2x minus 7 is supposed to be equal to 0. So we already have a solution there. So solving this part, what are we going to have? 2x is equal to the minus 7. To the other side was going to be positive, or simply add 7 both sides. So that was going to be positive 7. So divide by 2 here. X was going to give us 7 over 2. Just like that. So we've got two solutions, x which is equal to 0, or the x which is what? 7 over 2. So you can even use the quadratic formula if you want. Like I stated before, on this type of an equation that we are having, as we can see, if you're using the quadratic formula, the constant, it means it's a 0. We do not have that part of the constant, the part of c. C will be equal to what? To 0. You can use that and prove if you are going to have the same answers. We are supposed to have the same answers actually. 1.12, correct to 1 decimal place. We are supposed to solve this equation. Remember, a quadratic equation, guys, the format, this here is not exactly what you're supposed to have. You're supposed to have in the form of ax squared plus bx plus c is equal to 0, just like the previous case. One side must be equal to 0. So what it simply means, I'm supposed to rearrange this equation before solving. So take the 12x to the other side, it was going to be negative. So that's x squared minus 12x. The minus 21 to the other side was going to what? Positive 21. That's equal to 0. Using the quadratic formula, you can use the completing of the square method. It's up to you. So I'm just going to apply quadratic formula, which is easier for most of us, guys. So remember that x is equal to minus b plus or minus the square root of b squared minus 4ac everything over what? Over 2a. So from this, a, the coefficient of x squared, which is 1 in this case, all right? B, the coefficient of x, which is minus 12, and c is what? The constant. So that means you're going to substitute these values into the formula. Like I said, our A is what? Our A is equal to 1. Our B is negative 12. And our C is what? Positive 21. So these are the values that you're simply going to substitute into the formula. X is equal to minus B. So that's minus our B is what? A negative 12. So take note, plus or minus the square root of, I'm going to have B squared, which is what? Negative 12 squared. So this is negative 12 squared minus 4 times A, which is 1 times our C, which is 21. So this whole part is going to be divided toward 2A. So it's over 2 times A, where our A is what? Is 1. Just like that. Just like that. So let's simplify, guys. Like I said, it is best for you to simplify what is under the square root, the values under the square root. So that was going to be minus minus, which is 12. That's positive. Plus or minus the square root of, simplify the numbers that we are seeing. They're under the square root, the numbers only under the square root. So this is what you're going to have. All right, it is because I fixed my calculator before. Let me just go back to the normal mode, number 8, then press 2. All right, so we need this part here. So that's minus 12 squared, minus 12 squared, minus 4AC. That's 4 times 1. Our C here is what? Positive 21. So we just open a bracket like this. So that was going to give us positive 60. So that's 60 over 2 times 1, all right, which is 2. So that's a 2. So simplifying, now we can just use our calculator, guys, at once to simplify everything, all right? Starting with the plus, what are we going to have? So just put a fraction. This is 12 plus the square root of 60. All right, let's go down and put a 2. So this is it. As a decimal, let's change here, or SD. It's, remember they said to 1 decimal place. They gave us an instruction here to 1 decimal place. So that'll be 9, this is going to change to a 9. Or let's fix our calculator, guys, to what? 1 decimal place. On number 6 here, then press 1 to 1 decimal place. Going to change again. That's 9,9, just like that. Okay, so this is 9,9, or X is equal to, we do the same thing to change here, just change to a minus and change this, that's 2,1. So remember, we have already fixed our calculator to 2 decimal place. So this is the idea, guys. Just like that. Using your quadratic formula, you can solve this equation. So it depends. Prove with the the completing of the square method. Remember where the quadratic formula is used, completing of the square method also, it can be applied in that manner. On 1.13, this is an inequality that you're given for 4 marks. All right, so let's consider our inequality aside here. Let's see what we were given. So this is 1.13. You were given 4x squared minus 12x plus, all right, this is 12x plus 8 is greater than or equal to 0. So remember, when solving these quadratic inequalities, guys, what you need is to have the critical values, this and that. But before we look into that, we can also reduce our inequality. Just like an equation, it can be reduced if we've got a common factor. Just like our case. In our case, 4 is common. 4 is the highest common factor. So we can choose to reduce each and every number by what? By 4. So that was going to be x squared, 12 minus 12 divided by 4, that is negative 3. 8 and 4, that's positive 2, which is greater than or equal to 0. So this is a reduced inequality from what we had. Nothing has changed. So we can just use our factorization here to obtain the two brackets. Remember, before the critical values, you can even factorize this part. The coefficient of x squared in our case here is 1. So that's an advantage because we are going to have x here and x. Then considering, remember, from this, guys, your factorization as a topic. 2 here, your constant. What are the factors of 2? The products of 2, which add up to what? To -3. We need two numbers. You multiply two numbers, you're going to get what? A +2. But when you add these two numbers, you must get a -3. So as you can see, guys, there's a 2 and a 1 there. But to get a negative, it means one of these numbers, the two numbers must be negative. Negative, negative. If you multiply this, that's a +2. If you add these two, if you take this one, you add to this one, that's a -3. So these are the numbers that we want, guys. -2 and what? -1. So that's -2, -1. So from this, guys, the critical values can be obtained. -2 to the other side is going to be what? A +2. Or x is going to be -1 to the other side is going to be what? A +1. So these are the critical values. Using any of the method, guys, are you going to use the number line? I explained the methods. Are you going to use the graphical method? I don't know which one are you going to use to find the exact solutions at the end. But as for me, guys, I'm just going to use the graphical method. From this part here, from our graphical method, we can see, guys, from here, we can compare to say our f of x, this whole part here, represents f of x. And it is f of x is what? Greater than or equal to 0. Our f of x is greater than or equal to 0. Where here, you can see on our quadratic, guys, the coefficient of x squared is 1, which we're meaning to say we are going to consider a smiley shape like this. Okay? So this is what you're going to have, guys. At 1 and 2. So 1 at this side, 2 this side. So as you can see, guys, where f of x is greater than 0, where it is bigger than 0, that is where it is what? Above the x-axis, on top of the x-axis. Where do you find the solutions on top of the x-axis? Remember, I said this is this side or this side when you're given a function like this. Go through your introduction, guys. All right. So this side, which values are you talking about? Values which are less than 1. These are the values to the left side of 1. These values, they are what? Less than 1. So therefore, we are saying x is less than 1. But remember, there is an equal to there on your question. So also, you're supposed to have an equal to on your solution. Or our x is what? Compared to 2, these values to the right side of 2, they are bigger than 2. So we're going to have an equal to also. So that's greater than or equal to 2. So guys, I want you to use any method to have your final solutions at the end that you are used to. You're supposed to have the same answers. All right. So make sure that you go through the introductions. I explained each and every method that is to be used when solving your inequalities. All right. So they were given our equations. Remember, under the surds, we also have equations that are under surds. All right, so this was actually a minus. So this is just ignore this part, just ignore. And this is an equal here. So it is like this, guys. Like, I don't know, this question, it was just like 1.14. So this is the square root. I'm going to take it like this, 5 minus 2x like this. So we are saying the square root of 5 minus 2x minus the x over 2, all right, minus x over 2 is equal to 4. This is what we have. So let us try to solve. Remember, when solving these equations where we have got surds, we are supposed to make the surd the subject of the formula to have it on its own, on one side of the equation, on its own. So what is affecting is this minus x over 2. Take it to the other side. So it is going to be what? A positive. So we're going to have the square root of 5 minus 2x is equal to, the moment you take this, it will be a positive. So that will be 4 plus x over 2 like this. This is what you have. To remove this square root, to get rid of that square root, what are you supposed to do? You're supposed to square both sides now to get rid of the square root. You have to square. Squaring both sides is to get rid of the square root. So meaning to say we are going to have what? 5 minus 2x, which is equal to the square of this. So it is either you're going to have two brackets that you expand there, it is up to you, or you are simply going to use, remember, these expansion of these binomials, a plus b squared is equal to what? It is equal to a squared plus 2ab plus b squared. First term squared. So what is our a? What is our b? According to our question, this is our a and this is our b. This is what we have. So we are supposed to have what? A squared, which is 4 squared. So 4 squared is what? 16. Plus 2ab. 2ab. So it's supposed to be plus 2 times a. What is our a? Remember, this is our a, this is our b. So our a is 4. And what is our b? Our b is x over 2. So you multiply, guys, 2 times 4 times 1 over 2. This was going to cancel. Remain with 4. So 4 times 1x, that's what? That's 4x. Just like that. Then you move on to the last term squared, plus b squared. So this is plus b squared, the last term squared, x over 2 squared. So x is going to be raised to the exponent of 2, which is x squared over 2 squared, which is what? Which is 4. Just like that. You have expanded, guys, the brackets. Or just open two brackets, 4 plus x over 2, another bracket, 4 plus what? X over 2. You expand these two brackets, just as usual from your FOIL method. So this is where you are, guys. This is where we are. And as we can see, we have got a quadratic equation. The highest exponent is 2. But there is a fraction also there. So I'm going to get rid of that fraction. Let's start by having one side to be equal to 0. So just going to leave this side to be equal to 0. Transpose all these terms to the other side. So meaning to say we are going to have what? X squared over 4. It's a positive. Let's start with the highest exponent of 2. All right. There is a 4x here on the right side. There is a 4x. So if we take the minus 2x to this other side, the minus 2x, it will be what? Positive 2x. So that's 4 plus 2, which is what? 6. So it was going to give us 6x. Same thing with this constant 16. There is already a 16 on the right-hand side. So take the this 5 to the other side. It is going to be what? A negative 5 there. So meaning to say, we are going to have 16 minus 5, which is what? 11. Now let's get rid of the fraction. Remember, guys, these terms or any whole number that you be having or a term can be written, guys, as a fraction. If you are given 2, 2 is same as 2 over 1. 3, 3 over 1. I talked about this. So this is same as over 1. This is same as over 1. This is same as over 1. So what is the LCD? What is the LCM of 1, 4, 1, and 1? This one. These are the numbers. What is our LCM? So you can see, guys, the lowest common multiple is going to be 4. So you multiply, guys, each and every term by what? By 4. You multiply by 4 here. You multiply by 4 here. You multiply by 4 here. You multiply by 4 here to clear the fractions. To clear the fractions. We want to clear fractions. We want to clear the fractions. So meaning to say this, guys, that's a 4. Then 4 times 0 is what? That's a 0. Any number times 0, that's a 0. So you're going to have 0 is equal to the 4, and the 4 here was going to cancel. That's x squared plus 6 times 4, which is 24. So that's 24x plus 11 times 4, which is what? 44. This is where we are. We have a normal quadratic equation that we are used to. Let's solve, guys. Remember, if we say this is equal to this, we can start with any side. We can start with what is on the right-hand side. We can say x squared plus 24x plus 44 like this is equal to what? 0. It's one and the same thing. So, guys, we're going to use any method. You can use your quadratic formula. Factorization method, as we can see here, the coefficient of x squared is 1. So using your factorization method, it was going to be easier. Just put x and x here. Then you consider, remember what you consider the what? The constant, the factors, the products of 44. But they must add up to positive 24. Which products do we have, guys? Two numbers. You multiply two numbers, you get positive 44. But when you add these numbers, you must get 24. So that's 22 and 2. 22 times 2, that's 44. We add 22 plus 2, that's 24. So this is it. So these are the numbers that we need, guys. That's positive 22 and a positive 2. So from these, let us find the x values. The positive 22 to the other side will be what? Negative. Or x is going to be what? The positive 2 to the other side is going to be what? A negative 2. So these were the solutions that we are obtaining from solving of the quadratic equation. Not as of our equation, we must verify. Remember, under surds, we must verify. Go back to the original equation. Test these values and see which one is the exact value. So remember this one as it is, guys. So let's test our values and see, or just try to verify. Remember the original expression that we had, it was 5 minus 2x minus x over 2, which is equal to 4. So let's start when x is minus 22. When x is minus 22, want to see if we are going to get a 4 or not. So let's substitute, guys, in place of x. That's the square root of 5 minus, right? That's going to be minus 2 into what? Minus 22, like this. Minus, our x is what? Minus 22. So this is minus 22 over 2. So let's see what you're going to have from this. So these values, as they are on your calculator, the values which are on your calculator, which are the exact values, are the ones that we deal with. So guys, as of our calculator, we must go back to the normal mode. Remember, we fixed here. So let's go back to the normal mode. Shift, go to setup, number 8, then press 2. All right, so let's simplify this. That's the square root of 5 minus 2 into what? Minus 22. That's into minus 22, like this. Then we move aside. That's a minus. We subtract. What are we subtracting? Minus 22 over 2. So this is minus 22 over a 2, like this. So let's see what are we going to have. So this is 18. We are obtaining 18. That's not equal to 0. That's not equal to 4, I mean. 18 is not equal to 4. 18 is not equal to 4. So meaning to say, for the value of x that we substituted of minus 22, the two sides are not equal. So this value is wrong. X cannot be equal to minus 22. So this is the idea. You do the same thing, guys, when x is what? When x is minus 2 this time. When our x is minus 2, so we're just going to put minus 2 here. Let's see what are we going to have. So in place of x, guys, let us put a minus 2. So let's put this one and remove this one. All right, so that's a 4. So as you can see, you're obtaining what? A 4. Exactly this one. 4 is equal to 4. The left-hand side and what is on the right-hand side here is the same. So x is equal to minus 2. So this is it, guys. You must test this before you just conclude to say these are the solutions that I'm having. These are the x values. Test those values. So x cannot be equal to minus 22, but x can be equal to what? X is equal to negative 2. Just like that. So these are the typical questions, guys. Make sure you go through your question papers before the tests that you are going to have in March. All right, let's move on to 1.15, which is 5 marks in this case. All right, so let's see our question. Let's just try to have just a little space here. All right, so you were given something like this. That's 1.15. You were given 2 to the exponent of 2x plus 1. All right, plus 5 times 2 to the exponent of x minus 3 is equal to 0. So, guys, this is a revision by now. From the introductions, I just hope the basics are there. Remember, we can separate, like I said, when you are given a positive like this, it means you are actually multiplying 2 to the exponent of 2x times 2 to the exponent of 1. All right? Plus 5 times 2 to the exponent of x minus 3, that's equal to 0. There is a 2 to the exponent of x here, and here there is a 2 to the exponent of 2x. So we can rewrite this, right? We can rewrite this one in terms like this one, in terms of this, as 2 to the exponent of x. Because we can see it here, guys. It's there. The 2 to the exponent of x, this is the one that we need. We need to separate that one. So it will be 2 to the exponent of x raised to the exponent of 2. That 2 that is remaining will be your exponent. But what about this one? What is going to happen with this one? Which is a product. Because this one is a product. You're saying you're multiplying. Whatever that you're having is going to be multiplied to 2 to the exponent of 1. And what is 2 to the exponent of 1? 2 to the exponent of 1, guys, is just a 2. Just a 2. So it is just like we're having a 2 here. A times B, remember, is what? B times A. So multiplying by 2 here, this side, or you using that 2 on this side, it's one and the same. All right, I hope you're together on this one. Plus, just like here, guys, where we can see the constant, then the part of what? 2 to the exponent of x. This is what you're just trying to have. Otherwise, you can have, or you can write it in any way that you understand. When you can properly see this part where the 2 to the exponent of x is on its own, 2 to the exponent of x, the 2 to the exponent of x, we can see it. Introduce a constant there to be easier that way. So we can just let k be equal to 2 to the exponent of x. So what does it mean? What does it mean? In place of 2 to this party, we are just going to put a k. So there is a 2 outside, so it's 2k squared. Here, you put a k here. Close that with your finger and put a k there. So that's what? 2k squared. Plus, close this part here, put a k. So what does it mean? This will be 5k. Do we have a k here? We do not have, so just rewrite as it is. So that's equal to 0. Just like that. Just like that. So with the factorization concept that you understand, guys, quadratic formula, you solve this equation. It's in your hands. So guys, with your factorization method, we know that you're going to have 2 brackets here. How are you going to factorize this? Guys, this one is in your hands. So many ways of factorization, shortcuts, this and that. So Guys, I do not know. Just going to talk about the cheat method since most of you said it is easier to work with. Remember from our cheat method, you said since the coefficient of this one, the coefficient of k squared is not 1, it is a certain number, which is 2, a 3, whatever that you have. We have to still remove this 2 that we are given here, multiply to the 3. So that is the cheat method. So it will be k squared plus 5k. The 2 multiplies the minus 3 will give us what? Negative 6. Factorize as usual because now the coefficient of k squared is 1. So you can have a k here, a k here. Then you consider what? The factors of what? Negative 6. Factors, products of negative 6. But they must add up to negative 5. Remember this one you are used to. So which one? As we can see, negative 6, one of the numbers must be negative 6 and minus 1 or minus 6 and 1. But which part? When we add, we must get what? A positive 5. When we add, we must get a positive 5. It's what? 6 and minus 1. So you take those numbers, plus 6 and minus 1. Then you bring back the 2 that you removed back in place of k. Remember, you had to steal this. You stole this before. So you bring back wherever you see k, you must bring back the 2. So there is a k here, you bring back the 2. There's a k here, you bring back the 2. Then you factorize where possible. The first bracket, 2 is common. Let's factor it out. So that will be k plus 3. 6 divided by 2, that's a 3. Second bracket, nothing is common, so it remains as it is. So this 2 becomes useless, guys. Take it away. Get rid of it. These 2 brackets are the ones that we need here. K plus 3, 2k minus 1. Just like that. Just like that. So, guys, like I said, obtaining these 2 brackets is in your hands. There are so many ways that can give us these 2 brackets, or you can use the quadratic formula. It's up to you. What we just need here is to find what? The values of k. So 3 to the other side, guys, was going to be negative 3. Or from this bracket, we're going to have 2k minus 1 equal to 0. So 2k is equal to 1. Minus 1 to the other side comes a positive. Simply divide by what? By 2. So k is equal to what? 1 over 2. Just like that. We have a k which is minus 3, and we have a k which is what? 1 over 2. Are these part of our solutions? No. We introduced something. That is why we said let. We introduced something. So we are supposed to bring back the x that we had. Remember, we are solving for what? For x. X, not k. K is something that we introduced. So you're going to bring that part where we had the what? Where we had the k here. 2, where we had the x, 2 to the exponent of x is equal to what? Minus 3, representing k. Or the same k represented as 2 to the exponent of x is equal to what? Is equal to 1 over 2. We have to bring back that is equal to 1 over 2. So this is the condition that we are now having. So from the first one, can we solve this? Can we solve this? No. 2 to the exponent, can we have a negative? When you raise 2 to a certain number here, a certain number, and you get a negative, is that possible? This does not exist, guys. So it cannot. There's no solution there. What about here? From 2 to the exponent of x, which is 1 over 2, we know from our exponents, 1 over 2 is same as what? It is same as 2 to the exponent of negative 1. When these bases are the same, the exponents automatically will be equal. So therefore, our x is equal to what? Negative 1 from this one. Just like that. So this will be our value of x. You are solving for x, not for k. Don't end here. You're supposed to continue, guys, up to the last stage. Make sure. So these are the typical questions, guys. Once you introduce k, bring that part on your final solutions. All right. On another part, question 1.2, we are given this A is equal to 4 over x squared plus 2, where x is part of our real terms. Determine the maximum value of A. Explain your answer. So for us to have a maximum value, the denominator, guys, is supposed to be what? Minimum. If we are given the number, if our denominator becomes as minimum, guys, as it can be, it means A will be maximum. So what can make this denominator to be what? To be minimum, guys? There is x squared plus 2. We are adding a 2. X squared plus 2. We are adding a 2 here. Meaning to say whatever that we can have here, we are going to add a 2. So for this to be minimum, guys, it means there is nothing here. It is just a 2 that we are having. There's nothing. So at the end, our A will be equal to what? 4 over 2, which is what? Which is 2. This can be the maximum value. On a condition that the denominator is what? Is minimum. The denominator is supposed to be minimum. The denominator must be minimum. Thus, x, since it is raised to the exponent of 2, take note, guys, our x is raised to the exponent of 2 there. So we can't get it. There is nothing there. When x is 0, we have to get rid of it. The moment you put any other number, guys, if it is a 1, if it is, remember, the moment you square that number, it becomes a positive, even if it is -1. So there will be values, bigger values that are increasing. I mean, the smaller values, there will be like, let's take a closer look, guys. Let's put any value there, all right? In place of x there, put any value, 1 squared plus 2, like this. Then you use your calculator like this, 4 over what? That's 1 squared, right? Supposed to be in a bracket. Okay, no problem. Plus 2, like this. You get 1,3333, like that. But let's say we had this one as a 0, this one, as if there was nothing, there's a 0 there. What are you going to get? A positive 2. Guys, this is the maximum value that you can ever get. Because of this plus 2 here, it is affecting here. Maybe if here there's nothing, but here you'll be affected that whatever nothing, you must add 2 to that nothing. So that is the effect. All right. So guys, this is the issue of the denominator. When you see something like this, just remove this, divide this 2, you're done. All right. So now for which value of x will A have a maximum value? We said this is the maximum value of A, but it is maximum when x is what? This is what you're being asked. When x is what? When x is what? When x is 0, because we say there is nothing there on x. So when x is what? When x is 0. So just like that, guys, this was just a matter of knowledge type of a question, understanding this. As you can see, straightforward. Solve x and y simultaneously. We are supposed to solve for x and y. So we've got 2 equations, guys. This is our equation 1. This is our equation 2. So as you can see, equation 1, it can be easier for us to make y to be the subject. I mean, x there. X to be the subject. So let's make x the subject. X is equal to what? The minus 2y to the other side was going to be positive. So that's 2 plus 2y, which is same as what? 2y plus 2. 2 plus 2y, guys, is same as what? 2y plus 2. Remember? A plus b. And what? B plus a. So here you can write it as what? 2y plus 2. Even as it was, guys. Okay, let me, no problem. We'll end up confusing you guys. Because most of you guys, you'll be now crying in the comment section. This is the same. Do not worry. Just leave it like that. So this will be our equation 3. So what are we going to do? Remember, we made this the subject from equation 1. From equation 1. So we are going to substitute equation 3, all right, into equation 2. All right, into this other one, equation 2. In place of what? In place of x, wherever we see x, we are going to substitute what? 2 plus 2y. Wherever we see x, this is what you're going to substitute. Wherever we see the x, here, this one, this is what you're going to substitute. So in equation 2, this is what we have, guys. This is given as x squared plus xy minus 5x plus 3y is equal to 3. This is x squared. This one is squared. So it was going to be 2 plus 2y squared in place of what? X squared. Plus xy. Guys, I told you guys, if you are having xy like this, is same as yx. You can even start with y to multiply. You can even start with y. So it is the same as it's plus y into x. What is our x? This part. 2 plus 2y. It is just the same thing, guys. Do not worry about this, right? Minus 5x. This is where we are. So that's minus 5 into x. This is our x, which is 2 plus what? 2 plus 2y. Plus 3y is equal to 3. So, guys, we can even get rid of this 3. Take it to the other side. It will be what? A minus 3. That's equal to 0. There's nothing there. So this is what we have now. This is where we are. Expand the brackets. Remember, guys, those a plus b squared is equal to what? A squared plus 2ab plus what? B squared. First term, 2 squared was going to be 4 plus 2ab. That's a and b. Here's 2 times 2y like this. So we're going to multiply 2 times 2 times 2, which is 8. So that was going to give us 8y plus b squared. The last term, 2y squared, was going to be 4y squared. It's like this, 2y squared. So that's 2 to the exponent of 2, which is 4y squared. All right, then distribute here by y this bracket of 2 plus 2y. So we just multiply each and every term by what? By the y that is outside. So that's plus and 2, which was going to give us 2y plus and 2 here. That's 2y squared. Second part, again, there's a bracket here. Distribute here on 2 plus 5y by what? By negative 5. So this is negative 5 times 2, which is negative 10. Negative 5 times 2, which is negative 10y. All right. This one, just rewrite as it is plus 3y minus 3 is equal to 0, as it is like that. So this is it, guys. Let us collect our like terms. If they are like terms, part of y squared, this is 4y squared plus 2. 4 plus 2, that's 6. Okay, this is the only part that we have. So that's 6y squared there. All right. Then we move on to the part of y. Okay, let's consider the part of y there. This is it, guys. You just have to consider our like terms. This is 8y here, 8 plus 2, which is 10, minus 10. This one cancels, so you're going to remain with this 3y. Remember, I said 8 plus 2, that's 10, minus 10, that's a 0. So you're going to remain with what? With 3y. So that's plus 3y, this one. On the constants, do the same thing. This is 4. This is 4 minus 10 minus 3. So 4 minus 10 minus 3 was going to be what? Minus 6 minus 3, which is negative 9. All right, just use your calculator, guys. That's a negative 9, which is equal to 0 like this. So you said 4 minus 10 minus 3. So it will be what? Negative 9, and that's equal to a 0. So, guys, this is our equation. As we can see, we've got a quadratic equation. We can even reduce this equation, guys. Okay, just try to reduce this equation by 3 each and every term. So this is by 3, by 3, by 3, like this. So you're going to have 2y squared plus, this is going to give us 1. So that's y there. 3 and 3, that's minus 3. 9 divided by 3, that's minus 3, which is equal to 0. 0 divided by 3, that's a 0, okay? So using your factorization concept, techniques, guys, whatever that you're going to apply, guys, I talked about this factorization to say it is in your hands, whatever that you're going to have here, okay? So you're going to have two brackets, 2y plus 3. Another bracket was going to be y minus 1. Make sure that this is what you have, or you're using the quadratic formula. So solving for y there, the first bracket is going to give us what? Minus 3 over 2. So take this 2y plus 3, that's equal to 0. So 2y is equal to what? 3 to the other side was going to be minus 3 divided by 2 by 2. So y is minus 3 over 2. This other bracket, what are we going to have? The minus 1, take it to the other side, will be what? A positive. So y is equal to 1. So these are the possible values of y that we have, y values. When y is minus 3 over 2, find x from there. From this y, which is 1, find x. From which equation? Which is the best equation to use? The best equation will be 2.1. Where we made, not 2 point, like this equation 3. Yeah, see it. Where x is the subject, x is equal to 2 plus 2, I remember. So it is best for us to substitute there. X is equal to what? X, remember, is equal to 2 plus 2y. This is from our equation 3. So substitute the value of y that we are given when y is what? Minus 3 over 2. So that's 2 plus 2 into minus 3 over 2. Guys, this is exam. This is an exam situation where you are having a test, guys. Use your calculator straightforward. 2 plus what? A 2 into, that's open a bracket, minus 3 over a 2 like this. Close the bracket. That's minus 1. So this is the condition, guys. You do the same thing. When x is what? When y is 1. What is the value of x? In place of x, in place of y there, you're going to substitute a 1. So that's 2 plus 2 into the y value, which is 1. So let's solve for x. This is just a matter of a calculator again. In place of x, just put a 1 here, remove everything, put a positive 1 like this. So x is going to be what? X is going to be equal to 4. So these are the solutions, guys. For the y value, which is minus 3 over 2, x is minus 1. You can even write it as a point. Remember, a point in point form, xy. Our x is what? Minus 1. What about the y value? Minus 3 over 2. A condition here where x is what? 4. What is the y value? Y is what? Y is 1. That's the condition. Can you have it that way? It's up to you guys. The final part is up to you. It's in your hands. Simplify that way. So that is it, guys. Just make sure you go through more questions there. That was going to help. 5 marks. All right. Another part, determine the integers. They want you to determine the integers. All right. A and B, so that the square of this is equal to. So guys, you're already given the answer to say your answer is supposed to be in that format. So what would be A and B? If you are given 3 minus the square root of 2 squared, how do you simplify? So it is either, guys, you're going to have the 2 brackets, or you're going to use those basic rules, guys, or you expand 2 brackets, 3 minus the square root of 2, another bracket, 3 minus the square root of 2. So remember your expansion, the FOIL method. 3 has to multiply everything in the second bracket. So that's 3 times 3, which is going to give us 9. 3 times this square root of 2. There's a minus there. So it's minus 3 square root of 2. You are done. You move on to this minus square root of 2. It multiplies this 3. So it's minus square root of 2 times 3, which is what? Minus 3 square root of 2. minus square root of 2 times minus square root of 2. Remember, negative to negative, that's a positive. What about square root of 2 times square root of 2? What are we going to have? That's a 2. Guys, I talked about this from our laws of surds. Square root of a times square root of a is equal to a. All right? So we have a number. If there's a number there, 2 times square root. If these two numbers are the same, you get what? A 2 as your answer. So that is it. Let's simplify, guys. As we can see, we've got the part of our real terms. We just need to consider numbers together, which are the constants, like as we consider where we have got these are our like terms in our case, the numbers that are under the square root, the irrational numbers. They are on their own. So this is the case. So we add 9 plus 2, which is what? 11. For the square root part, you do the same. You just combine minus 3, which is what? Minus 6. Minus 3, minus 3. Under the square root of 2. Remember, the square root of 2 is the same. So you work with what? Minus 3 and minus 3 as the coefficients, just like coefficients. So this is it, guys. If this was being simplified, this is our answer. This is what you're supposed to get. So they gave us a presentation of this answer to say it is supposed to be written in this format, a plus b, the square root of 2. Is it the same format? Yes. So what is our a? Our a is what? 11. We're answering the question. So therefore, it means our a is what? Our a is 11. What about b? What is affecting the square root of 2 is our b. What is affecting here? Sorry, this is b. What is affecting the square root of 2 here? This one. So our b is what? Negative 6. What is affecting the square root of b? The square root of 2. That is our b. So, and our b is what? Negative 6. Just like that. You have the format. They gave you a format of the answer. Your answer is supposed to be like this. So you follow that format. This is the case of our question. Just like that. So questions can be of this nature, guys. Just have to make more questions. Question number 3, we are given that the roots of the quadratic equation are given. These are given as this. So guys, I talked about this as an introduction. Now it is available, the introduction about the nature of roots. Remember, from the part of what? Your delta here. Your delta, the part that is under the square root is one that you work with. So they are saying on 3.1, calculate the value or values of P for which the roots will be what? Real. As long as it's a real solution, as long as you consider that it's a real part. What is the condition? Remember, our delta must be greater than or equal to 0 for us to have any real solution. It can be greater than 0 or it can be equal to 0. So we must have that equal to on our answer. So remember the delta, guys, the b squared minus 4ac. Isn't it this part under the square root? It is the one here under the square root here. The part that is under the square root. So you already have it here, 2p minus 1, as it is 2p plus 1, I mean, this one. That's our delta under the square root. So this 2p plus 1 must be greater than or equal to 0. You have an inequality to be solved. Solve for p. So that's it. 2p is greater than or equal to 1 to the other side was going to be what? A negative 1. So simply divide by 2 by 2. That's we're going to have the value of p, which is greater than or equal to minus 1 over 2. So that's we're solving. Our p is supposed to be greater than or equal to minus half. Just like that. Okay. Then considering the other part, give one value of p for which the roots will be rational. If we consider the nature of our roots, guys, wherever the answer is rational, whenever you have this rational on your answer, you will see that it's only on two conditions, where our delta is equal to 0 or where our delta is equivalent to what? A perfect square. A perfect square. Those are the only two conditions that can give us rational solutions. So which one can we take advantage of? When it is equal to 0. Because already we have our delta there, guys. Just equate to 0. So using the first part, 2p plus 1 must be equal to 0. So 2p is equal to what? 1 to the other side, that will be minus 1. Divided by 2, divided by 2. So our p is what? Our p is minus half. Just like that. It's now an equation. We want to know exactly what is that value of p. Once you put a p here, guys, which is minus half, it will give us a 0. This whole part will give us a 0. So it means your answers will be x is equal to what? Minus 4 plus or minus 0, which is what? Minus 4 or minus 4. They are rational numbers. That's a rational number. When the square root, when what is under the square root is equal to 0, or when it is a perfect square, those are the two conditions. So the easier path was to work with what? A 0. Because a perfect square, which one are you going to work with? So best way to work with what? With a 0. Just like that. All right. On question number 4, simplify the following without using a calculator. Yes, they are saying without using a calculator, but guys, you can just use a calculator to verify, like for the simplification, especially writing these numbers, such as 144, guys. Even if they say do not use a calculator, you are supposed to use a calculator to prove that. So 144, we can write this as a product of its prime factors. Remember, we need this in simplest form. So this is how you can just use your calculator, guys. All right, 144 is equal to, right? Then you say shift fact. So as you can see, guys, it gives you as a product of its prime factors here. 2 to the exponent of 4 times 3 to the exponent of 2. Just like that. So that was 3. Sorry, it was 2 to the exponent of what? 4 times 3 to the exponent of 2. Raised to the exponent of n. Everything is affected by that exponent of n. Everything to the exponent of n. All right, we have got a bracket here. Just take it as it is. So we're going to have a bracket 3 to the exponent of negative 1 to the exponent of 2n minus 1. Everything over what? 4 to the exponent of 2n minus 1. 4 can be written, guys, in the base of 2. That's 2 to the exponent of 2. All right. But remember, there is an exponent already there, which is what? 2n minus 1. Just like that. So let's simplify, guys. Remember your laws of exponents. An exponent here, and any part raised to a certain exponent inside of the bracket, every part will be raised to the exponent of n. So it will be 2 to the exponent of what? 4 times n, which is 4n, times 3 to the exponent of 2 times n, which is 2n. Same with this part, exponent to exponent multiply. So it's 3 to the exponent of negative 1 times 2, which is negative 2n. Negative 1 times negative 1, that's positive 1. Everything over what? 2 to the exponent of 2 times 2 here, that's 4n. 2 times negative 1, that's negative 2. Remembering our laws of exponents, that if you are multiplying the bases which are the same, you add, on a condition that you are dividing the bases which are the same, like here, we are going to subtract the exponents. It's a division. Guys, this is an exam, remember, revision now. So here we've got what? 4n there. All right, the one on the numerator on top. Minus, because we are dividing here, we subtract our exponent. So that's 4n minus what? 2. In the numerator, what is happening? It's a product. We are multiplying there, the bases which are the same. So what are we going to do? We add here. We are multiplying. It's a product, this one. Of this 3 to this 3. It's a product. So we have to add the exponents. So that's we're going to have 3 to the exponent of what? 2n. We add this one. Addition does not affect, you can just combine, or you can add, guys, like this, minus 2n plus 1, so that you properly see that this one is a subtraction, this one is an addition. We are multiplying on top. These two of a of this one, of the base of 2, they are under a division. So let's subtract, guys, and see what are we going to have. So this was going to be 2 to the exponent of what? Well, that's a minus. Yes, it's going to be negative times. This is going to be minus 4n minus, that's a plus 2. So 4n minus 4n was going to cancel. You remain with what? 2. So 2 to the exponent of 2. The same thing here, plus and minus, that's minus 2n. Plus and plus, that's plus 1. So 2n minus 2n was going to cancel. You remain with 3 to the exponent of 1. 2 to the exponent of 2, that is 4 times a 3, which is going to give us what? A 12. Just like that. So make sure, guys, do more revisions, more question papers, prepare yourselves for the exams, tests, which are ahead of time. All right, let's see on this other part. They will be testing you like this, guys. The nth root of this whole part. All right, so that's 4.2. So how can we simplify? Remember, guys, just like the previous case, 6 there is what? So this is the nth root. All right, there is nth root there. So 6 is same as 2 times 3. So that's 2 times 3, guys. 2 times 3 to the exponent of what? Of n. 3 is in simplest form, so let's just leave it like that. 3 to the exponent of n plus 2. All right, well, guys, this root is small. It's supposed to cover everything. So everything is supposed to be covered. 2 to the exponent of 2 to the exponent of n plus 9, like this. All right, there's something here, guys. 3. All right, there's something about the 2 to the exponent of n. Let's just simplify further and see. Remember the exponent again. Each and every part here has to be raised to the exponent of what? N. So it was going to give us the nth root of 2 to the exponent of n. 3 also raised to the exponent of n. Like that. Okay? This is a product. Plus, separating this is 3 to the exponent of n times 3 to the exponent of 2. Remember, this is what it means for us to add these exponents. Everything over what? 2 to the exponent of n plus add 9, which is same as what? 3 to the exponent of 2, if you want to write it in that way. Just the same. So this is where we are, guys. And looking into the numerator, we were going to notice that there's something common there. From the numerator, remember, these are now 2 terms, this one and this one. 3 to the exponent of n, this one is common. So we can factor it out from the numerator. 2 to the exponent of n. What do you remain with if you remove this one? What do you remain with? 2 to the exponent of what? Guys, I want to remove this. I want to remove this. 3 to the exponent of n. So what are we going to remain with? This one. 2 to the exponent of n. What about this side? This one. With what? A positive. So that's plus 3 to the exponent of 2. We are going to remain with this. Everything over what? In the denominator here, there's nothing that you can factor. It's just like we have a 1. There's nothing. It is just the same thing, guys, as it is. 2 to the exponent of n plus what? 3 to the exponent of 2. But these two are the same. The numerator here and this one, they can cancel. So thus, it was going to give us the nth root of 3 to the exponent of n. What is the nth root of 3 to the exponent of n? Remember, how do you get rid, guys, of this nth root, this one? 1 over. So it is 3 to the exponent of n to the exponent of 1 over n. And exponent to exponent, you multiply n times 1 over n. That was going to cancel. So it's 3 to the exponent of 1, which is what? Which is 3 at the end. Just like that. So it was going to give us just a number, which is what? Which is 3. So you see, guys, how these questions can be given as exams, test. They're testing you. Do you know all applications of your laws? On 4.3, we are given the square root. So this is part of your surds. Square root of 7. So that's we've got the square root of 7 over the square root of 63. Remember, guys, square root of 63, that's we've got a perfect square there, 9 times 7. What is the square root of 9? That is 3. What about the square root of 7? It remains like that. So it was going to give us 3 square root of 7. This one, the square root of what? 63. Or even use your calculator, guys. No one is even no one is gonna know that you have used a calculator there. Square root of 63. What is the answer there? 3 square root of 7. Minus what? Minus a 7. Take note here. There is what? A minus 7 here. So that's minus the square root of 7. Everything over what? Everything over as it is, guys. This is 3 square root of 7 plus a 7 like this. So as we do understand simplification of fractions, addition and subtraction, you must consider the LCM. What is the LCM of our denominators? Just going to take them as they are. As you can see, they are different. So this is 3 square root of 7 minus 7 into what? 3 square root of 7 plus a 7. So let's divide. This one and this one, guys, it was going to cancel. You remain with this. So it was going to be the square root of 7 there in the numerator into what? What you are remaining with. 3 square root of 7 plus a 7. Guys, you do the same thing. The 3 plus this one that you have here. Division, it was going to cancel this part. What do you remain with? Here, this one. So it is the one that you multiply to the numerator as it is. So it was going to be minus square root of 7 in the numerator, this one. Remember, there's a negative here. Into what? The denominator, like into this bracket that was remaining in the denominator. So we take that bracket that was remaining because this one is cancel this one. So remember, that's 3 square root of 7 minus what? Minus 7 like that. So this is it. Let's expand our brackets so that we can collect the like terms at the end. Remembering that I explained, guys, square root of a times the square root of a is equal to a. So when you are multiplying square root of 7 to the square root of 7, you know that you're going to get what? A 7. Square root of 7 times the square root of 7 must give us what? A 7. So when you have this case, guys, it means what? When we have square root of 7 times the square root of 7, it's a 7. So it's 3 times the 7. Remember, square root of 7 times square root of 7 is what? It's 7. So you're now left with a 7 times what? The 3, this one here. So 3 times 7, that's 21. Square root of 7 times square root of 7, that's what? A 7. Okay? This is our case. Okay, so this is 7, there's no square root there, guys. Here, we do not have a square root here. This is just a 7. So it was going to be square root of 7 times a 7. So that's 7 square root of a 7 there, all right? Minus square root of 7 times this. So it was going to give us what? Minus, remember? 3 square root of 7 times the square root of 7 is what? It's a 7. So this is it, guys. So that's 21, but having what? A negative. So that's minus 21. You do the same thing here. The minus square root of 7, it multiplies the minus 7. Minus, minus, that's a plus. So that's 7 square root of 7. Everything over what? Our denominator as it is. Remember, these are surds. The denominator is supposed to be what? It's supposed to remain as a rational number, not having these square roots. So we can use the difference of two squares concept, guys. Remember, this is A minus B, A plus B. So what's our difference of two squares? A squared minus B squared. So we're going to take the A, you square it. 3 square root of 7 squared. That's our A squared. Minus B squared. 7 squared. Our difference of two squares. So you see our sets, guys, how they are simplified. You need to work as much questions as you can. So what we're going to have at the end, simplifying the numerator, 21 minus 21 cancels, 7 plus 7. Remember, these are like terms. Square root of 7 and square root of 7. Like terms, they're the same. So we can just add the numbers. Coefficients, 7 plus 7, which is 14, under the square root of 7. So that's 14 square root of 7 over what? The denominator part. 3 square root of 7 squared means 3 square root of 7 times 3 square root of 7. 3 times 3. That's 9. Square root of 7 times square root of 7. Remember, I talked about this. Square root of 7 times square root of 7, not it's 7. So you're going to have 9 times 7, which is what? 63. Minus what? 7 squared. What is 7 squared? 7 squared is what? 49. So this is it, guys. Let us simplify what we can in the denominator. We can simplify 63 minus 49. Subtract this. That was going to be 14. All right. So lucky enough, these two are the same. They can just cancel. We get a 1. So 1 times square root of 7, that's the square root of 7. So this is what you were going to have in simplest form, actually, that is working with a single surd, having your answer as a what? As a single surd. As you can see, we are having our final answer in this case as a single surd. So questions can be like that. Questions can be like that. And the surds, you must do revisions. Actually, each and every topic, guys, grade 11 is the major part, the core part, the heart of mathematics, where it brings all. Grade 12 is just revision. Just revision. Grade 12 is just revision, guys, if you do not know. The seriousness part, the seriousness, the revisions, the understanding of our mathematical evaluations are in grade 11. We find grade 12 now being challenging. The background was grade 11. So, guys, once we were working with these March exams, you see that here there's a challenge. Guys, this is the right time that you do work your revisions. You do work your topics, introductions, understand the basic of each and every topic. Understand the basic of each. This is the right time to work them. Because they, guys, I'm telling you right now, as you see these, you see this question, you are going to meet them as they are, like this in grade 12. But there's no time for introductions. There is time for revisions. So that is why I'm saying everything must be done here. because it will be revision, guys. You'll be surprised, like day one up to last day, like, what is new? Just one or two things. Everything is what you had in grade 11. So, guys, let's revise as much as we can. Gonna see that it will be easier in our path. It will be very, very easier in the next path that we are going to have of our grade 12, because, guys, we know grade 12 is the major course, major part, like we're going to be working with final exams. But it's not like it's the major one. This is the major one. This is the major one, this one. So if you're to consider question number 5, let us see how you're given the information there. Because you're given that if, that's a statement that you're given that you need to consider. If this is equal to 0, this whole statement. So let's figure out about this statement. That's 5.1, the square root of 3 times 1 over cos alpha, like this, is equal, or sorry, there's a plus 2 here, and that's equal to 0. So, guys, we can make the cos of phi the subject, the cos of alpha, this one alpha, the subject. What is affecting is the 2, this 2 here. We can get rid of this to the other side, all right? Or simply subtract 2 both sides of your equation. So meaning to say we are going to have, this is same as over 1. So square root of 3 times 1 is the square root of 3 over the cos of alpha, like this, is equal to, remember, we no longer have this. It is on the other side. 0 minus 2, that's minus 2. So it is same as minus 2 over 1. Remember, guys, the issue of whole numbers. The same as what? Over 1. So what we need is to make this one the subject so that we can properly see the ratio as we do understand the concept of our soccer tower. All right. Remember the concept of your soccer tower. You must properly see the ratio. Is it for cos? Is it for sine? If it is for cos, you must properly see this, the cosine of theta being equal to adjacent over what? Adjacent over the hypotenuse. We must properly see it. We are not seeing it so far. So what can we do? Let's cross multiply here. Cos of phi times 2, that's negative 2. Cos of alpha. Guys, where am I getting the phi? I'm now used to this phi that I was working with in my previous class. All right, so divide by negative 2 both sides so that we get rid of this. Remember, we need the cos on its own. So it follows that the cos of alpha is equal to the square root of 3 over minus 2. But according to our ratio of the cos, guys, adjacent over hypotenuse, hypotenuse cannot be negative. Hypotenuse can never be a negative. So the negative here will be written on top. So it will be minus the square root of 3 over what? Over 2. Adjacent can be positive, can be negative. But hypotenuse always positive. So we have a ratio. According to this ratio, it is telling us, it is giving us that this cos is what? A negative. It is a negative. So if we're to consider this, guys, where cos is negative from the cast concept, we see that cos is negative where we do not have C and this one. These ones, they are positive. Cos is positive here and for all. So here cos is what? Negative. Also here it's negative. So we're going to have two regions at the end where cos is what? Negative. So that is why they are giving us another ratio here, another interpretation about this ratio to say, and the tan of alpha, the same alpha, when we are comparing it to tan, it is what? The tan of alpha is less than 0. What does it mean? Even if we do not know the ratio, but we are told that it is less than 0, what does it mean? It is a negative value. The tan of alpha is a negative. So we need a region now where both ratios are negative. As you can see here, cos is negative, tan is negative. Which part? Here we know this is the quadrant of a tan. Tan is positive. So it fails now because tan is positive here. What about the second quadrant? It's the quadrant of what? A sine. What does it mean about a tan? It means tan is negative. Cos is also negative. Remember this. So this is the best quadrant that can suit our answer, where both cos and tan can be negative at the same time. It can be only in the second quadrant. So if it is in the second quadrant, guys, now we've got a hint that it is in the second quadrant. Therefore, let us have our triangle in the second quadrant, just like that. So this is our alpha. According to the ratio of cos, adjacent over hypotenuse, according to this angle, this is your opposite, all right? This is your opposite. This is your adjacent. This is your hypotenuse. So the hypotenuse, adjacent. Adjacent is what? Negative square root of 3. This part, negative square root of 3. Hypotenuse is what? Hypotenuse is 2. So we are forced to calculate this third side. From where? That is where we apply now your Pythagoras theorem. Remember, guys, r squared, our hypotenuse, which is the length of the radius, is equal to what? X squared plus y squared from Pythagoras. We're now on our Pythagoras theorem. What is the hypotenuse? It's 2. So 2 squared is equal to x, the minus square root of 3 squared, plus the part of y that we need, which is our opposite. So we're going to solve 2 squared, that is 4, is equal to, remember guys, minus when raised to the exponent of 2, that's a positive. Square root of 3 squared, that's a 3. You can even use your calculator, guys, or use your surds. Then this to the other side was going to be a negative. That's 4 minus 3, which is 1. So that's 1 is equal to y squared. So if 1 is equal to y squared, what about the part of y? Introduce the square root. So y is equal to what? The square root of 1 plus or minus 1. But as we can see, guys, above, on top there, we are above the x-axis. Y is what? Positive. So y can be 1. Y can be 1. Positive. So this is what you needed, guys. You have to apply the Pythagoras theorem, this and that. If you know your Pythagoras, even by head, you can fill the diagram by head without using these calculations. So the question was, with this information, with the aid of a diagram, determine with the aid of the diagram what? The value of 10 sine alpha minus 3 tan squared alpha. Determine this value. This is our question now. Our question is to find the value of what? 10 sine of alpha minus 3 tan squared alpha. So remember, from your ratios, guys, SOHCAHTOA, sine, opposite over hypotenuse. So wherever we see this sine, it's opposite over hypotenuse. That is the ratio of a sine. What about a tan? So this is minus 3 into tan squared. Tan opposite over the adjacent. So you are going to have the opposite over the adjacent, but this is tan squared. So it means you're going to square this. That is the idea there. Opposite over adjacent. So that's 10 into what? Remember, opposite over hypotenuse. So let's fill in, guys. Opposite over the hypotenuse. Our opposite is 1. Hypotenuse is what? It's 2. So this is 1 over 2 minus 3 into opposite, which is 1 over what? Adjacent. Adjacent, which is what? minus the square root of 3 being squared. So that's it, guys. 10 times 1 over 2, 10 times a half. That's a 5. All right. Minus, that's a 3 times. We simplify this 1 over, you can even use your calculator, guys. That was going to give you positive 1 over 3. There you can even use your calculator. No one is going to know, or just multiply, guys. All right. Minus 1 over square root of 3 times minus 1 over square root of 3. Minus 1 times minus 1, that's 1. Square root of 3 times the square root of 3. That's a 3. All right. So that is it, guys. Or just use your calculator there. Then simplifying this 3, this minus 3 and the third was going to cancel. So it was going to give us minus 1 times 1, which is minus 1. So it's 5 minus 1, which is equal to 4. So the whole of this question, or the whole of this part, was going to give us a numerical value, which is 4 at the end, just like that. So they will test you this. So they will give you two ratios, trigonometrical ratios, so that you compare which quadrant is going to satisfy for both conditions that you're given there. So that is the idea of your question there. All right. Then we are given another part. If that's another question. If cos 12 degrees is equal to m, if we are given that the cos of 12 degrees is equal to m, remember, SOHCAHTOA. So there we are not even given the quadrant or what to say in this quadrant, what? Because they know we can use these in a right-angled triangle. That's where these ratios were taken from. So you can even just draw any right-angled triangle of your choice and indicate the angle of 12 degrees. Let's say this is 12 degrees. According to this 12 degrees, this side is opposite. So you've got the opposite, 90 degrees and 12 degrees, they are adjacent to each other here. And this is our hypotenuse. Understanding this alone, guys, you can fill in because you know cos is what? Adjacent over hypotenuse. This m is same as m over 1. Adjacent over what? Hypotenuse. So m represents what? Our adjacent. In this place of our adjacent, we have got what? M. The hypotenuse is what? Is 1. M over 1. So hypotenuse is 1. So we have to calculate the opposite, guys, just like the previous case using your Pythagoras theorem again. 1 squared minus what? So it's going to be 1 squared is equal to m squared plus opposite squared. Take this to the side. 1 minus what? M squared is opposite squared, whatever that you put there. Square root to square root. So opposite is the square root of what? 1 minus m squared. So this side, guys, was going to give us 1 minus m squared, whatever way that you're going to use. So fill in your diagram and answer the questions. Reduce these angles. 5.21. The sine of 168 degrees. We have to reduce it, guys. Which quadrant are we talking about? 168, it lies in the second quadrant. 168 degrees. So how can we write it as an acute angle that is remaining here? That's 180 minus 168. 180 minus 168, which is what? Which is 12. So in the second quadrant, is the quadrant for what? Remember from your cast, it is for sine. In the second quadrant, it's for sine. The sine that we are seeing there, it is the one. It is for sine. So sine there is what? Positive. It is going to remain as a positive, but of what? The acute angle, which is 12 degrees. So what is sine 12 degrees? Remember sine, opposite over adjacent. So we need opposite over hypotenuse, opposite over hypotenuse. So according to 12, this is our opposite, the square root of 1 minus m squared over the hypotenuse. Our hypotenuse is what? Is 1. So guys, dividing by 1 does not affect anything. It means this part will remain as it is, the square root of 1 minus m squared. Just like that, guys, you do this, guys, you answer all these questions using this reduction. The cos of 192, you have to first figure out where is this 192? Which quadrant is it? Where does it lie? 192 is more than 180. So it lies in the what? Third quadrant here. Less than 270. So we need this acute angle in the third quadrant. How do you find the acute angle? It is going to be 192 minus 180. You find the acute angle, which was going to be 12 degrees. And in the third quadrant, we are dealing with a cos. In the third quadrant, for tan, cos is what? Negative there. So this is negative cos of the acute angle minus cos. So that was going to be minus cos 12. Already cos 12, guys, is the one that you are given. Remember, originally here, cos 12 here is here. Cos 12 is what? Is m. Originally, it's the one that you're given. It's what? It's m. We have the answer already. So meaning you say it's minus what? Minus m. These are the typical questions. These are your typical questions. So guys, this is test. We're just going to find time. Explanations as topics, as a separate topic, guys, for exam, guys. I can't add much here just for the sake of time. Tan 372 on 5.23. So the same thing. 372. This is more than 360 degrees. More than any angle that is more than 360. Subtract until we have an angle which is less than 360. We have to subtract what? 360 degrees. So it was going to be 372 minus 360, which is 12. So this is same as what? As tan 12. It's already an acute angle, this one. And we have it, tan 12 is there. Tan, opposite over adjacent. What is your opposite? Take your opposite, square root of 1 minus m squared over what? The adjacent, which is what? Which is m. So everything is over m. Just like that. All right, sorry for that. Just like that. So you had to apply the reduction concept. Reduction concept. 192, you're saying this is cos 192. This is 180 plus what? Plus 12. 180 degrees plus 12, which is going to give us minus cos 12. Or just work with what? Acute angles. Or just work with what? Acute angles. So you just need more revisions there. Another part you are given, simplify. This is sine squared of 180. So it was just like this. Sine squared of 180 degrees plus x. All right, minus. This is cos of minus x. All right, cos of minus x times the tan of 90 degrees minus x. Tan 90 degrees minus x times, this is the sine of 540 degrees plus x. This was our question. So just like the previous case, can we reduce whatever that we can, apply our identities? If there are identities, remember sine squared simply means we are raising that to the exponent of 2. But let's start with 180 plus x. This is which quadrant? We have 180 plus x in third quadrant from our cast. 180 plus x. Remember, this is x. Second quadrant, 180 minus x. This is 180 degrees plus x. In terms of positive angles, this is 360 degrees minus x. In terms of what? Positive angles. 180 plus x, third quadrant. The quadrant of a tan, where sine is what? Is negative. So it means this was going to give us negative sine of x. But this is what? Squared. It is being squared. Minus the cos of minus x. Minus x, this one, it's a negative angle there. We are dealing with a negative angle. Remember, for negative angles, this is minus x in the fourth quadrant. This is x minus 180 degrees. This is minus x minus 180 or minus 180 minus 1x. This is x minus what? 360 degrees. According to negative angles. You must know your quadrants, guys. So minus x lies in the fourth quadrant. For cos, remember your cos. There's no change. So it's what? A cos minus x. Cos in the third quadrant. So cos, I mean, in this fourth quadrant, cos is what? Positive. So it means it was going to be positive cos x. It remains as a positive this one. It becomes a positive because of the fourth quadrant. Cos is what? Positive there. So this is it. Whatever that you're going to get here, you multiply tan 90 degrees minus x. Remember your core function. Tan 90 minus x gives us what? The cot of x. So those ones, guys, you just need to know your ratios. Just like sine 90 degrees minus x is equal to what? The cos of x. These are your core functions. Go through each and every part of your core function. Sine 540 degrees. It's more than 360. So subtract 540 minus 360 degrees. It was going to give us 180. No, 540 minus 360 was going to give us 90 degrees. All right. So you have to subtract properly each and every part. So 540 minus 360 was going to give us 180, guys. Where am I getting this? This is 540. So it was going to give us 180 this one. So this is 180 degrees plus x. So if it is 180 degrees, guys, plus x, it is the same here. 180 degrees plus x in the third quadrant. Sine is what? Negative. So sine there is negative. So that's negative sine of x. Just like that. You simplify each and every part on its own. Each and every part on its own. So negative here being raised to the exponent of 2. Negative square, that's a positive. So that's sine squared of x. Minus, all right? So here's a product. Here it's under a product. Minus times this, minus times minus, that's a plus. So you're going to have the cos of x times the cot of x. Cot. From our ratios, cot is what? The cos of x over the sine of x, remember. Times the sine of x. Remember, we used this negative times negative, which gave us what? A positive. So this is what you have, guys. This is a single term, this one. It's a single part, this one. So what are you going to have? The sine squared of x plus, as you can see, this one can cancel numerator to the denominator. Cos times cos, that is cos squared x. And this is our Pythagorean identity, which gives us what? A 1. We know this one, it is equal to 1. Just like that. So guys, go through your questions. Go through more questions. Prove that this identity is equal to -1. So I'm just going to take the left-hand side of our question on 6.2, which is the sine of x minus 90 degrees times the tan of negative x. All right, the tan of negative x. Everything is over what? The cos of 400. This is 450 this time. So that is 450 degrees plus x. So this is our left-hand side. We must get what? A -1. Let's see. So working with this, guys, remember your core functions. We know that the sine of 90 degrees minus x is equal to the cosine of x. What about when it is negative like this? Like when it is x minus 90, x minus 90, x minus 90. What do you think, guys, is going to happen? This is opposite. This one is just going to carry a negative because this is going to represent minus sine of what? 90 minus x. It will give us a minus. So in place of the cos that we had, it is just going to carry a negative, guys. This is just a vice versa of what is we had. 90 minus x. This is x minus 90. We just multiplied by a negative. So also multiply by a negative. So that was going to be negative cos of x. Not cos of x, but negative. All right? Times the tan of minus x. I talked about this, guys, that minus x is a negative angle, which lies in the fourth quadrant, which is of what? Of cos. Tan there is what? Is negative. So this is negative tan. That's negative tan of x. Everything over what? 450 is more than 90 degrees. So subtract 450 is more than 360. So subtract 360 degrees, I mean. So it is more than 360 degrees. You have to remove the 360 degrees. You are going to get 90 degrees. So this is same as cos 90 plus x. Remember your core function, cos 90 plus x is a negative sign. That's a negative sign. It lies in the 90 plus x in the second quadrant, and cos is negative there. So sign takes a negative, all right? So let's deal with the sign, guys. Negative, negative, that's a positive, all right? So we are left with positive over what? A negative. Positive over negative is what? It's a negative. So we're going to have negative like this. What is this cos? Can we simplify it? No, let's just leave it like that. Cos over sine. Let's just leave it like that with a negative. Cos of x over the sine of x. But here there is a tan that we have under a multiplication. So we are going to multiply our tan of x over 1. So tan of x is just like tan of x over 1. Remember, guys, tan from our ratios is what? Sine over cos. So instead, we can write this. This is minus cos of x over the sine of x times what? The tan, which is what? Sine of x over cos of x. So we can even ignore this over 1. Then write it like what? Like this. If you want, you can put that over 1. It's still one and the same thing. All right? So this can cancel. Sine to a sine, a cos to a cos. We are getting what? A negative there. So that was going to give us truly a negative 1, which is exactly what we had on our right-hand side. So these are the questions, just as we had from our right on the right-hand side, minus 1. So to prove is just like to simplify. There are questions where you are being asked to simplify, remember. There is only that you are not given the answer. The proof, they give you the answer, say the answer is this. You are supposed to simplify until you get that answer. That is the only part of your proof. So considering the other part, determine the general solution for this equation, the 6.3. So we are given 3 sine of x, which is equal to 2 cos squared x. So looking into this question, we can see that, all right, remember we need the general solutions. There's a sine, there's a cos, which makes it complicated for us to work with this type of a question. So let's try to introduce only one trigonometric that you're going to work with. So it is difficult for us to change a sign, this sign that we are seeing, to be a cos. But it is easier for us to work with what? A cos squared. So working with a cos squared, remember from our Pythagorean, cos squared of x plus the sine squared of x is equal to 1. So where I see this cos squared, I can make it the subject of the formula also here. So it is equal to what? The cos squared of x is equal to, meaning say I have to take this one to the other side. So it has to be a minus 1 minus the sine squared of x. This is what represents the cos squared, this part. 1 minus sine squared. So if I have it, I can substitute it in. So it means I'm going to have 3 sine of x is equal to 2 into the cos squared, which is this part. 1 minus what? The sine squared of x. At least, guys, I'm having only a sine in my equation. Not to say I have a sine, I have a cos. So this one is difficult, guys. Which part can we use to change a sine to a cos? It's difficult. But a cos squared, because there is an identity where cos squared is, we can take advantage of that. So it is now an equation left under sine only. Expand and see. So this is 3 sine of x is equal to 2 times 1, which is 2. 2 times this negative 2 sine squared of x. Just like our normal quadratic equation, the highest exponent is what? Is 2. Just like a normal quadratic equation, ax squared plus bx plus c is equal to 0. One side must be equal to 0. So we take this to the other side. It was going to be what? Positive 2 sine x squared. All right? Transpose this to the other side. Already there was what? A 3 sine x there. Then the 2 to the other side becomes what? A negative. That's equal to 0. A normal quadratic equation that you are used to. So you can solve this by quadratic formula. You can solve by the factorization method. You can even introduce k in place of the sine of x. Here, where we see the sine of x. We can let k be equal to the sine of x so that you properly see what you're working with. So this is 2 sine squared. So it's 2k squared plus 3 sine x, which is 3k minus 2 is equal to 0. Using your quadratic formula or you're applying the factorization method, it is up to you. So using factorization, you're going to have 2 brackets, k plus 2, another bracket, 2k minus 1. You solve for this. This to the other side was going to give what? A negative 2. From this bracket, minus 1 to the other side was going to give us what? A positive 1. Then we divide by what? By 2. This is what we have. Guys, you can use quadratic formula, whatever that you want. You have your values of k. You bring back. Remember, we said let k represent the sine of x. So it means the sine of x must be equal to what? Negative 2. Or the sine of x must be equal to what? 1 over 2. But remembering, guys, in our mathematics, the sine of x cannot give us a negative. Like we cannot have a negative 2. The sine of x is bounded between what? From minus 1 to positive 1. Cannot get out of that interval if it is the sine of x. Yeah, if it is x. Or if you're having a challenge with that, guys, just consider, remember, you're supposed to have what? Arc sine of this to have what? Your reference angle. You use your calculator, guys, to prove. Then you see your calculator cannot simplify that. If you do not understand what I'm saying, yeah, just use your calculator. All right. Let's bring our calculator here. This is arc sine of 2. Remember the reference angle, shift sine, arc sine of what? You take it as a positive. Just ignore that negative. As you can see, does not exist. We are out of the range minus 1 to 1 that we are supposed to be working on the y values. They are not supposed to exceed this. So it means the sine of x cannot be equal to negative 2. Does not exist, this one. So we are only going to work with this part. Half is in between, guys, minus 1 to 1. It is in within the range. So we have to find the reference angle and so on. So as you can see, guys, our sine here is what? A positive, the positive value that we have there. So let's determine our reference angle, guys, which is arc sine of 1 over 2. So this is shift sign 1 over 2 like this. That was going to give us what? 30 degrees. Where is it that sine is positive according to our quadrants? We understand that sine is positive where? From our cast on all and in this quadrant of S. So in the first quadrant for all, your angle, if it was X, it will be equal to the reference angle in the first quadrant. So meaning to say our X was going to be equal to the reference angle as it is in the first quadrant. But remember, this is a general solution. We are dealing with a sine. So is the reference angle that you're given there plus what? 360 degrees times K. Just like that. So where this K is going to be representing all integers. This is in the first quadrant. Where sine is positive, it is also positive in the second quadrant. So in the second quadrant, our X is going to be what? As a general solution. How do you find the angle in the third quadrant? Given a reference angle, it is 180 degrees minus the reference angle. So we must subtract 180 degrees minus what? Reference angle. We subtract the reference angle, which is what? 30 degrees. So 180 minus 30 was going to give us what? 150 degrees. So X is equal to 150 degrees plus 360 degrees times K. This is the condition now of your solutions. If they were just exact solutions, we're just going to take the 30 and the 150, but we need the general solution where we cater all. We cater everything for K. Possible solutions that can be obtained. So this is it, guys. Let us continue to work out as many revisions, as many question papers as we can, as we are preparing for the exams, for the tests, which are ahead of time, for the activities that we are having at our various schools where we are. We're going to work with different provinces. Like I said, we are going to bring back another one from Gauteng again, the March 2024 exam, the March 2024 test, which is the controlled test. This one, it was just a test before, just a warm-up for preparations. So guys, do as many warm-ups as you can. Prepare yourselves because those marks, they are part of your SBA. They count on your SBA at the end. So do as much as you can to make sure that your SBA is as high as it can be. As high as it can. So that in your final exams, you're not going to stress that much. So let's revise, guys.